Hi, welcome back to the Introduction to Python Programming. This is section 9, functions. So we're going to start to get a little bit more complicated, but hang in there, we'll get through it, and I'm sure you'll have a great time. The lesson objectives for this video include understanding the following: functions, many programs in your program, or sometimes they get called little black boxes or little boxes of code, inner functions, recursion, generators. And then, of course, that last bullet is the commit, which is related to the version control project. We'll use that to get access to the lesson resources for this video. Functions, many programs in your program. So a function is a block of code that you give a name, and then when you need that block of code to execute, to retrieve, or generate some data, you just call that block of code by name. And it's isolated from other parts of your program so that it doesn't mix in. And that's just demonstrated on line 6 of the example. We try to print first, which we are trying to reference the variable first on line 5, but we don't have access to that variable out there because that's only in the function definition. So functions, named block of code that does something specific. In previous lessons, we used the print function. That was a block of code that's hidden from us that does something specific. It prints out data to the console so that we can read it. And creating a function, we use the keyword def, and then we name the function. We provide the parameters, which would be a and b in this bullet example. And then in the below definition, we return the results of a plus b. Now that function is just an example. We won't need the sum function because we could just do a plus b without a function call. Usage, once defined, you reference the function by name and provide the expected arguments. So this bullet references the function in the previous bullet. We put the value of a equal to the sum of the arguments 1, 2. So that should give us a value of 3. Now let's take a deeper look at the screenshot example as well, because it's a little bit more complicated. We have a function defined with the name get underscore name. We have an argument parcel, which has to be the value of the string. That's what that colon str means. It means this is going to be a string. It needs to be a string. If you try to pass in an integer, for example, the Python engine is going to complain about that. So once we pass in that string, we split it, and a split without any argument means that we're going to split on empty space. So we're going to create a list, a 2-item list. First is going to be equal to the 0 item, and last is going to be equal to the 1 item, or the first and second item. We start counting from 0 with lists or arrays, which is why we have to use 0 and 1 there. And then we're going to return a dictionary with a key value pair of first name and last name. So that's pretty straightforward. We're sending in a string, we're breaking that string down into a first name and last name and returning that as a dictionary. Then on line 3, we can see we make a print function call, and then we got to get that print function the data it needs to print. So in there we put a function call to get name, and we pass in John Smith. So we're going to, of course, get a dictionary with a first name, last name, John Smith. Okay, let's go ahead and move on. Inner functions. These are functions inside your functions. Define a function inside the definition of another function. This is a nice little trick that Python lets you get away with. Not other languages won't let you do this, but Python does. When do you want to use? You use an inner function to shorten repetitive code inside a parent function. So this follows the same pattern as regular functions. We want to practice the dry principle, which is don't repeat yourself. So functions in general allow us to practice that principle by writing out a block of code that we call whenever we need to use it by name, so that we don't have to repeat that block of code every time we need to use it. The inner function is the exact same thing, but applied within functions. So if you're writing a function and you find that you're repeating a lot of code in that function, that would be an indicator that you might need to use an inner function. And then the next concept is closure. Inner functions that is dynamic and can use variables that exist outside its definition. So what that looks like, if starting on line 18 we have outer 2, we have a equal to a plus 5, so we've defined a variable a, and then on line 23 we have an inner function being defined within that outer function, and on line 24 we're returning a plus 5, but in that inner function we never defined what a was. However, the inner function will understand what a is because it will look to the outer function to get the value of a. So that's how that will work. So again, Pretty simple concept. It's something that needs practice to get used to it, but basically with functions and inner functions, anytime you're repeating yourself, that's when you're going to look at using a function or inner function. If you're writing a program and you're repeating yourself a lot, that might be an indicator that you need to use a function. If within a function you're repeating yourself a lot, that's an indicator you may need to use an inner function. All right, let's go ahead and move on. Recursion. Recursive function, difficult concept with common appearance. And it's simple, it's just a function that calls itself. So if we look at line 2, we see a factorial function. We say if n is equal to 1, return n. Otherwise, return n times factorial n minus 1. Now on line 12, we also see the looping version of that. So we have both versions, or we have two different versions of the factorial function here. We have the loop version and we have the recursive function call. And the recursive one takes up less lines, I believe, right? 1, 2, 3, 4, 1, 2, 3, 4, 5. One less line there. So for example, if we have 5 and we pass 5 into as n, we'll get 5 times n minus 1, which would be 4, which would go through again, be times 3 times 2 times 1, and then we would just return 1. Okay, and there's a great examples of using recursive functions for checking user input, and we'll take a look at that when we write some of those programs. Right now we're just getting the basics, the Lego bricks, if you will, of how to build programs, and then we'll start to build somewhat complex programs that collect user input, and we do various things with those. But we'll discuss those when we get to them. Let's go ahead and move on. It's generators. This is a sequence creation object. We want to use these with large data sequences. Generator functions allow you to traverse potentially large data sequences without storing the entire sequence. So this allows you to save memory when properly used. So when do you want to use this? Create when you need a function to traverse a large set of data. Yield. Instead of a return statement, you use a yield statement. The function would not work in the same manner if a return was used instead of a yield. So if you tried to replace the yield with a return, it would just return the first value of the loop. So in the example, we can see that we have a list being passed in that goes from 1 to 5. That list is going to be called n when it enters the function. So for I and n yield I. So it's going to return all the list items. Okay, and that's going to allow us to run the sum function, which needs an iterable data object to produce its result. So that's just a quick example. Okay. All right, let's jump into the lab environment and take a look at the resources that we have there. All right, here we are. I'm still in section 8, so I'm going to go back to the outside section 8 right there. I'm going to open up my git bash shell. I'm going to git reset hard in case I made any changes, and then I'm going to check out the new commit. So that's going to be 0190A5. All right, so now I'm at section 9. A quick look at the cheat sheet. So there's some good information on there. Be sure to take a look at that because we do look at the generator a little bit in this cheat sheet as well. Let's take a look at the example. What would be a good example? Example 1. Open that up. So we can see that how this function works. So what would happen if we didn't pass in the right split? We did a comma instead, right? So let's go ahead and run that. Run example 1. Parcel 1. Okay, so we get an index out of range because it wasn't able to split. But what if we said we want you to split on the comma? Would we go back to working? Let's run it and find out. Yep, it worked. So we got a John Smith, but then we crashed on this, which doesn't work because it references a variable in this scope of the program, but that variable actually exists in this function, which is a different scope. So let me go ahead and erase that. Just make the error go away. All right, so they're finished, and then we did a split on the comma when we pass this in. Wonder if this would work, right? Let's put 2 commas in there. So first name John, last name empty space. And that's because this empty space is being made an element, so now there's 3 elements. But what if we made the 2 commas a split? Would that fix it? Sure enough, it did. Now 2 commas are the delimiter. All right. Well, that is a quick example. Let's take a look at another one before we move on to our questions. Example 3. Oh, the factorial ones. Okay, so let's say let's print 5, right? And factorial 5. Let's put that in there. That's just mad because I need to put another space there. There we go. Run. 120. Now we should definitely get the same answer if we do it with factorial 2. So that's the looping version. One example. Okay. Yep, that works. So if you never looked at recursive functions before, this version of the function is probably easier to look at. However, you will want to begin to get comfortable with factorial functions because or not factorial recursive functions, I'm sorry, but recursive functions, because they do see a lot of use in the field. All right. Let's go ahead and take a look at the exercises. Questions. Task 1, what are functions? Why use them? Yeah, that's discussed in the lesson. Write a function that accepts a list of words and a single character. Okay. The function should return the same list, but only contain the words that begin with the character that was also passed in. No additional data objects should be created. All right. So you're gonna write a function. It's going to take 2 arguments. One of those is going to be a list of words. The second argument is going to be a character, and the function is going to return the same list, but only contain the words that begin with the character that was passed in. So let's use a quick 2-item example: apple and pie. You're going to pass in a list of apple pie with the character A, and then that list is going to return with just apple because pie begins with a P and not an A. So there are functions related to the list. I believe delete, for example, is a function that you'll be able to use to get rid of that additional item, pie. You'll want to look that up. And again, the way we would do that is we just go to Google. We say Python list methods. Let's see what W3 School. So removes the first item, removes the element at a specified position. So these are the different methods of the list that we can use, and I'm sure you'll need to use 1 or 2 of those to complete that question. So task 3, create a generator function that accepts 2 parameters that indicate a range and returns the odd numbers in a list that exists between that range. So remember, the generator function uses the yield instead of the return. And this function needs to accept 2 parameters, a beginning and an end. So for example, maybe we pass in 50 for the beginning and we pass in 60 for the end, and then we want to return the odd numbers. So that would be what, 51, 53, 55, 57, 59, right? And that would complete that task. So go ahead and pause the video, take a stab at these tasks, because we're going to go over the answers in 3, 2, 1. Let's get going. All right. So here are the answers. Let's bring the answers up. Task 1 answer. This was the easy one, right? Functions are smaller bits of reusable code that help support the drive principle. Sometimes they are described as smaller programs within your larger program, as they commonly do something very specific. And an example that we've talked about previously is the print function. What does that do? It prints out to the console so that we can read the data, and that's all it does. Task 2 answer. Okay, let's see. We got a word list and a character for word in words. So we're using a for loop to iterate through our list. If word 0, 1, so we're starting at position 0 and ending at position 1, we're testing if that is equal to the character. If it is, we continue on to the next iteration. So this is a good example. We're using previous things that we learned in previous lessons, which is the continue statement and the iteration of the for loop and the if statements. So a bunch of concepts coming together there. But if it's not, and we don't continue, we're going to drop down to the next line. We're going to remove the word from words. That makes sense. Like, you can read it and see what's going on. Words dot remove word. We're iterating. Word is the current value of the loop iteration. All right. And then word underscore list words comma char. So what is that? That's a recursive function call. Now, if you didn't do it this way, you did it another way, and you got the same results, it's perfectly fine. But in this example, I used a recursive call to the function itself to go through the list again. And then once that's done, we break out. So that's probably not a very efficient way to do it, but it works perfectly and it's easy to read. Okay. Oh, and the reason I did it that way is because with iteration, you can't change the original list and then iterate to the next item in the list, because the Python engine gets confused because you've actually changed the list as you're working through it, which is why I ended up using the recursive function there. So be sure to take a good look at that and you understand how that's working and how that's working through that problem there. Task 3 answer. This one probably was a little bit easier. Custom range, A integer, B integer. So I'm requiring that the arguments A and B be integers, which makes sense. I don't want the programmer to send words into it, or the user to send words into there. We want integers. For I in range, so I used a function range, A comma B plus 1. Now, if you didn't do this exact again, it's fine as long as you get the right answer that matches the task question. And then I do if I, that's the modulus operator, 2 is equal to 1, yield I. So what is the modulus operator? This well, it looks like a percentage sign. It is a percentage sign, but it acts as the modulus operator. Well, it returns the remainder of a division, and it's returning the remainder of a division of 2. So when we're testing for an odd number, we can say 1 divided by 2, the remainder is 1. 2 divided by 2, the remainder is 0. 3 divided by 2, the remainder is 1. 4 divided by 2, the remainder is 0. 5 divided by 2, the remainder is 1, and so on and so on. And by testing what came back, we're testing for it to be equal to 1, we can then yield I, because we know that based on the return of that modulus operator, whether or not that number is odd or even, whether or not it's divisible by 2. Okay, I hope you got those. I know it's starting to get a little bit more complicated, but hang in there. We're going to keep reiterating over these same concepts, and we're going to keep strengthening our understanding of these concepts as we go. And let's go ahead and jump back into the slideshow and finish out the lesson. All right, here we are back at the lesson. We already went over this screen, so let's go ahead and jump to the next one, which is the section conclusion. In this lesson, we learned about functions and inner functions. Functions allow us to practice the drive principle. Don't repeat yourself. If we're repeating code, we probably want to put it into a function, which is a named block of code that we can then call from our primary code. Recursion are functions that call themselves, and generators are functions used to iterate over a long range of data without storing that complete range in memory. So they make that process a little bit more efficient. So that concludes this lesson. I hope you enjoyed it, and I hope to see you in the next one. Thank you.